Hello everyone, and welcome to our 11.4 notes on three-dimensional figures. Another way to say that is to just call these 3D figures. So we have been working with 2D figures. We just took a test on area, so that's all of our flat shapes. And now we're looking at three-dimensional figures. So what is that called? What is a three-dimensional figure called? That is going to be called a polyhedron. It is going to be a 3D figure whose surfaces are made up of polygons. And we just learned about all different types of polygons. And so let's look at some vocabulary first. What is going to be a face in a polyhedron? A face is going to be a flat surface. So that's what I've just highlighted in our picture. So the face is going to be the flat surfaces. What is an edge? An edge is going to be a segment that is the intersection or the cross of two faces. So when you have two faces that cross, they form a segment, and we're going to call that segment the edge. Okay, so this is the edge between those two faces. There's more than one in that picture. We'll talk about that in a second. And then what is a vertex? Well, we've talked about a vertex in 2D figures. So what is a vertex in a 3D figure? The vertex is going to be the point. So that's a point right there. So that is going to be the point that is the intersection of three or more faces. So the face is the flat surface, the edge is the intersection of two faces, so it's a segment, and then a vertex is going to be a point. So here's another way to say that. A face is going to be a plane. An edge is going to be a segment. A vertex is going to be a single point. So when we name a face, you need 3 or more letters to name a face. You need 2 letters to name an edge since it's a segment. And so I'm going to do this. There's a face, there's an edge, and then a vertex is always going to be a point. Okay, so what we're about to start doing is identifying the number of faces, edges, and vertices for each polyhedron. So let's go through this. We've got this shape. How many faces are in this shape? So when you count, we've got our face, the 3 faces, because we've got a base on the bottom, NPO, that's a triangle, and so I kind of look at that like the floor. So there's 1, and I've got the 3 walls coming out of that, coming to a point at the top. So there's gonna be 4 faces. How many edges are there? And you could highlight these if you need to. We have from here to here is 1 edge. From here to here is a second edge. From here to here is a third edge, M to O, so there's 3. And then you have 3 edges along the bottom as well. So if you want to highlight that, you can, if that helps you out. There's an edge here, here, and here. Here, here, and here. So a total of 6. 6 around the walls, 3 around the walls, 3 around the floor makes a total of 6. So how many vertices do you have? It's just those points that we just put on there, 1, 2, 3, 4. All right, let's do that again. How many faces are in this shape? So this kind of looks like a room. You've got a floor and a ceiling, and you've got 4 walls. So how many faces do I have? A total of 6. How many edges do I have? Well, I'm going to have 4 on the ceiling, 4 on the walls, and then 4 on the floor. So I look at this kind of like a room. So I'm going to have 4, 4, and 4 makes a total of 12. And then how many vertices do I have? Well, that's going to be all these points. The intersection of 3 or more faces. So those come to a point. If you touch those would be sharp. And so how many of those do I have? I have 4 on the top, 4 on the bottom for a grand total of 8. Okay. All right, then we have this cool looking figure that kind of looks like a house. And so how many faces do I have? Well, I have the front and the back of the house. And then I have 2, you have kind of like 2 faces at the roof. And then you've got the 2 walls on the side and then the floor. So we have 2, 2, and plus the faces, so 5 total, yeah. So front and back, and then the ceiling, and then the walls and the floor. So a total of 5 plus 2 gives me 7. Okay. What is my number of edges here? So let's count those. I'm going to highlight them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total edges. And so how many vertices do I have? I'll have the 2 points at the top. There's all my points there, T and then Y. So I have a total of 10 vertices. All right, so we have a formula called Euler's formula. I know it looks like Euler, but it's pronounced Euler. And this guy created the formula that states that the sum of the number, so remember when we say sum, that means add, the sum of the number of faces and vertices of a polyhedron is going to be 2 more, so 2 additional, more than the number of its edges. And so what is that formula? It's going to be F plus V. The sum of F plus V is going to be equal to the number of edges plus 2. So F plus V equals E plus 2. His formula starts with an E, And so the way I remember which letter is by itself with a 2 is that it's the one with the E. It's the number of edges plus 2. So F and V go on the other side and you add them together. So faces plus vertices equals the number of edges plus 2. Why does that help us? Because sometimes in a shape, especially in these pictures that I have coming up next, you might not be able to see through the shape. You might not be able to see the back of it. So think about like a Rubik's Cube. Counting things on a Rubik's Cube would be hard because you'd be rotating it a ton. And so you're actually able to find missing number of faces, number of vertices, or number of edges based on knowing 2 of the 3 pieces. And so we're going to start with our formula every time. F plus V equals E plus 2. And we are given in this shape that there are 8 faces, which makes sense because there's a floor and a ceiling and there's the walls. There's 6 of those. So there's 8 of those. They give us that the number of edges is 18, which makes sense because there's 6 at the top, 6 edges in the middle, 6 at the bottom, so a total of 18 edges. But we want to know the number of vertices, which we could count. Let's go ahead and just count them. 1, 2, 3, 4, 5, 6 at the top, 6 at the bottom. Our answer should be 12, but what if you couldn't see through the shape? So we'd go F plus V equals the number of edges, which is 18 plus 2. And so we're going to do 8 plus V equals 18 plus 2 is 20. And so to get V by itself, you're going to subtract 8 from both sides. And so when you do 20 minus 8, that is going to give you 12 for my number of vertices, which is exactly what we just said. There are 6 at the top, 6 at the bottom, so a total of 12. So we were able to just count in our first example, but in our second example, we cannot see the back of this shape. And so we're given the number of edges and vertices. So we're always going to start with the formula. F plus V equals Euler's formula, so E plus 2. He gets the fame and glory, so he gets to be the number with the letter with the 2. What is his number of faces? Well, that's what we're looking for. His number of vertices given is 20. His number of edges given is 30. So let's find our number of faces. So that's going to be F plus 20 equals 30 plus 2 is 32. And then we're going to subtract 20 from both sides. When you do 32 minus 20 for my number of faces, I should get 12. So even though I cannot see the back of this shape, there will be a total of 12 faces. All of those faces are pentagons. In our next shape, it looks like our faces are all made up of triangles, but we can't see the back of the shape. But we can use his formula, F plus V, so 20 plus 12 equals the number of edges plus 2. So 20 plus 12 is 32. That equals E plus 2. So how do I get the number of edges by itself? You subtract 2 from both sides, and you get the number of edges on this shape, even though we can't see them all, is going to be 30. So you've had one example where you found the number of vertices, you've had one example where you found the number of faces, and you found one example where you had the number of edges. So you can find any of those pieces as long as you have 2 out of the 3 pieces of information. Okay, so let's look at our 3-dimensional shapes. The first shape we're going to study is we're going to find the surface area and volume of prisms. So what is a prism? A prism is going to have 2 parallel congruent polygon faces called bases. It does not have to be the top and bottom. So I know that a lot of times we talk about the top and the bottom of something. You can always turn shapes, so it does not have to be the top and bottom. Connected by faces that are going to be parallelograms. Most of the shapes that we are going to look at are going to be rectangles. So it's usually going to be rectangles. Not always, but the shapes that we study are going to be, the prisms are going to be made up of rectangular walls. So when we talk about the walls, that's what I'm talking about. Okay, so how do I know that these shapes are going to be prisms? It's because they have 2 congruent parallel faces. So which pieces would you say are parallel in this first shape? I would say that this triangle is parallel to this triangle. So this is going to be a prism. What do we call him? How do we name him? We name him by the bases. So what shape is the base? Those are triangles. So you could call that a triangular prism. Okay. How many bases do I have? I have a total of 2 bases. How many faces do I have? Well, I have a total of, that's just how many polygons do I have in this shape total. I have a total of 5 because there are 3 walls between those bases. So it's going to be a total of 5. How many edges do I have? I'm going to have 3 at the top, 3 in the middle, so you can highlight if you need to. 3 at the top, 3 in the middle, 3 at the bottom. What is 3 plus 3 plus 3? That is going to give me a total of 9. And then my vertices are going to be the points. So there's going to be 3 at the top, 3 at the bottom. So that's going to be a total of 6 vertices. Okay. What shape is the next one given? Well, the next one we have is going to be, we've got several options here. So I'm going to do these 2. These are congruent and those are parallel to each other. So there's my bases. That is a set of bases. So I'm going to say 2. What I could do is I could push the shape over and I could have the top and the bottom. So this kind of looks like a tissue box. If I turned it on its side, these are also parallel and congruent, the left and right. The front and back are also parallel and congruent. So you could use any of these bases. We have 2 of these that I'm going to say are parallel to each other right there. And then our faces, how many do I have? That's the ceiling and the floor, and then the 4 walls is going to give me 6. How many edges? 4 at the top, 4 in the middle, 4 at the bottom. And so that's going to give me a total of 12. And then my vertices, I have 4 of the points at the top, 4 of the points at the bottom, and so that's going to give me a total of 8. So how do we name this shape? This looks like a rectangle. I can't say that it's a square because I don't have the markings. So we're going to call this a rectangular prism because there are 2 bases. Okay. My last shape we're going to have is going to have the ones that are parallel and congruent are these hexagons. So those face the same way. They're congruent to each other. You could take the bottom and switch it with the top, and that would still be the same shape. And so this is going to be called a hexagonal prism. So you name it by its base. It's all about the base. That's how you name it. How many of those bases do I have? 2. How many faces do I have total? Well, I have 6 walls and 2 bases, which makes 8 total faces. How many edges do I have? 6 around the top, 6 in the middle, 6 at the bottom. So if you wanted to, I kind of like think about it like circling this around. There's 6 here, 6 standing straight up and down on the walls, and then 6 here. 6 plus 6 plus 6 gives me a total of 18. Then how many vertices do I have? 6 hanging out up here. Those are the points. And then 6 hanging out at the bottom for a total of 12. If you wanted to check yourself, you could always use Euler's formula to check and make sure you counted correctly. Okay, so how is a cylinder different than a prism? Well, in a cylinder, it's going to be curved or rounded. So think about like a can of chicken noodle soup. 2 parallel congruent circular bases. So they're not going to be polygons because a circle is not a polygon. So these are going to be circular bases. So you still have 2 of them, and they have a curved surface that connects the bases. Okay, and so when I'm looking at this picture right here, if this is a can of chicken noodle soup, there's my circles, and you can see that the walls are not made up of polygons or rectangles. It is a curved surface. So there is one that is standing straight up and down, and then you have one that's kind of leaning over. Okay. Okay, so how many bases do I have? I still have a total of 2 bases, but there are, how many faces do I have? Well, it's only those 2 faces. I only have 2 shapes in that, and the walls are curved. So I'm not going to have any edges because there's no edges in a can, and I'm not going to have any vertices either. There's no, I can't put a vertex on this where it comes to a point where 3 or more bases intersect. So what I'm going to do, there's no faces that intersect where it comes to a point, and so there's no vertices, there's no edges, but there are only 2 faces. They're the 2 circles, and then the walls are going to be those curved surfaces. So we're not going to count those as faces. Okay. So what is a pyramid? A pyramid is going to be a polygon base and a triangular face. So instead of it having rectangular faces, we're going to have triangular faces. And they come to a point at the tip top that is going to be called the vertex. All of those triangular faces meet at a common vertex. So when I'm looking at that, all of these meet at a common vertex at the tip top point. Okay? You also name these by their bases. And so in this shape right here, this has a triangular base, and so we're going to call this a triangular pyramid. How many bases does it have? Well, it has the triangular floor, and then it has 3 walls, so a total of 4 bases. How many faces? 3 at the top plus the one at the bottom makes 4. Y'all, how many bases? Y'all, I just did that wrong. I'm so sorry, put in the wrong spot. How many bases do I have? I just have 1, and then plus the 3 walls makes the face 4 total. Okay, so 1 base. All of these have 1 base instead of 2. That's what makes them a pyramid instead of the prism. And then I have how many edges? I would have a total of 6. So 3 on the walls, 3 on the floor. How many vertices? I'd add those points here. I would have 4 total vertices. So 1, 4, 6, 4. How many faces are in this shape? Well, it's the base plus the walls. So the 4 triangles plus the, this looks like a rectangular pyramid. So I have the 4 walls plus the rectangle on the base. So that's going to give me a total of 5. Around the edges, I've got 4 on the walls, 4 on the floor, so that's a total of 8. And how many vertices? I'd put points in these corners. I'd have a total of 5. Okay. Next shape, we've got 6 faces. I've got 10 edges, and I'd add my points here. I've got 6 vertices. How do we name that? Well, let's name it by its base. It's all about the base. So this one was a rectangular pyramid. This one is a pentagon, so we're going to call that a pentagonal pyramid. Okay. All right, so how is a cone different than a pyramid? It still comes to a point, but it again is going to have a circular base. So very similar to a cylinder, it just comes to a point. So it's a circular base and a curved surface that connects the base to a vertex. So in a cone, how many bases do you have? Just the one. That is going to be my circular base, so it's just that circle. So there's just one of those. How many faces are there going to be? Just that one. How many edges are there? 0. And how many vertices are there? There's just going to be that 1 point. Okay, so that is what a cone is. And y'all are used to these because y'all have seen like party hats. You've seen like if you think about whenever you go to get water from like a field, if you're playing a sporting event and you use those little white paper cups, those are made up of cones and they come to the point. And we love crumpling those up and throwing them away. So those are cones, okay? So what is a sphere? A sphere is like a ball. It's a set of points that are going to be equidistant, which is just a fancy way to say equidistant from its center. So every single point on this ball is the exact same distance away from the center, which is in the dead center middle of that shape. So how many bases does it have? 0. There's no polygons in that shape. How many faces does it have? 0. How many edges are there on a ball? 0. How many vertices are there on a ball? 0. Okay. The last thing we're going to look at is cross sections. A cross section is the 2D image, so it's going to be a 2D shape, so it should be a polygon, formed by the intersection of a 3-dimensional figure and a plane. So it might be a polygon, it might be a circle, it's going to be a 2D shape that gets formed when you have an intersection of a 3D figure and a plane. So how I think about this is if you were to take this shape, this triangular pyramid, and you were to cut it off, what shape would be left? So I always kind of think of this like a cake. What would be left on the top of that cake if you looked at it from above? That would be a triangle. That would be a 2D triangle that got formed on top of this pyramid when you cut off the top of it. So what if we took a party hat and we cut it straight down? What shape would be left? What 2D shape would be left? This would leave a triangle. So I kind of think about it like if you were to stamp that shape onto a sheet of paper, what shape would it be? So if I were to cut off the top of a can and I were to color this in and I were to use it like a stamp on somebody's hand, what shape would that stamp be? That would be a circle because I cut that parallel to the bases. What shape would it be if you took that can and you cut it this way and then I used that to make a stamp? That would be a rectangle. So these are called cross sections. Okay. This next one's a little bit tricky because you're cutting this pyramid at a slant, and so when you cut it at a slant, the distance from here to here is going to be a little bit shorter than the distance from here all the way back. And so when you connect those dots, what shape is left there? That is going to be a trapezoid. So yes, it's a four-sided figure, but most specifically a trapezoid because we're going to have two bases that are parallel and one is a little bit longer than the other. So what if you took a party hat and you cut off the top of it? What shape would be left on top if you looked at it from above? That would be a circle. So we cut it horizontally, whereas on this one we cut it vertically and created a triangle. Okay. What if I take a pyramid and I slide a sheet of paper through it? What 2D shape would be left there? That would be a triangle. And then what if we take our can of chicken noodle soup and instead of cutting it straight across like we did on this one, horizontally, what if we took that and we cut it at an angle? It's not going to be a perfect circle that's formed. What is going to be formed? It is going to be an oval. So it's going to be at an angle, so that is going to create an oval. Okay, so your homework is going to be on a sheet of paper. It is going to be the 11.4 3D figure assignment, and so you will practice those problems, and I hope you are having a fabulous day.